And just to illustrate a little bit of that, to show you that you get similar results, this next slide here shows several examples of that, where there are two dot plots side by side. The one, as indicated by the labeling on the left, is a conventional gold standard labeled antibody, and the panel on the right in those dot plots is the HybriLink labeled antibody. It's the same clone, but instead of being covalently conjugated, it's HybriLink labeled. And as you can see in a variety of cases with bright and high abundance markers, with dim and low abundance markers, in multicolor cocktails, or in the lower right corner we show in complex matrices such as whole blood. And it may be a little hard for you to really read that one in the lower right-hand corner, but the take-home from the lower right-hand one is that even in a complex matrix such as whole-lysed blood, HybriLink antibodies work every bit as well as do conventional covalently labeled antibodies. We have a little more data here we can show you for just 1 second here. In this slide, the conventionally labeled antibodies are at the top, and the HybriLink labeled antibodies are at the bottom of the two rows of panels. As you can see, for a variety of fluorophores such as PE and APC, along with the small molecule fluorophores we've previously shown you, the results are very similar. I want to call your attention particularly to the third column from the left, which is looking at the antigen B220, labeled with, and the antibody for it is labeled with APC. There's no panel there for the conventionally labeled antibody because at the time we were doing this, and it may still be the case today, there was no APC-labeled anti-B220 antibody commercially available. So, for instance, if that was what you needed to complete your panel for a research project, you would have been out of luck before HybriLink existed. But today, HybriLink gives you the ability to put any fluorophore on any antibody. Now, one of the questions everyone necessarily wants to know about is, well, what's the probability of the fluorophore jumping off of the antibody? Because, of course, since we're relying upon oligonucleotide hybridization to attach fluorophores to antibodies, that's not a covalent association between the two components. It's non-covalent. And certainly we have examined that quite thoroughly and have validated that that simply doesn't occur in reasonable conditions here. On the left, you see an example of an assay that HybriLink developed to specifically assay for the ability of a fluorophore to hop off of one antibody and hop onto another antibody. And these are just using antigen-coated beads to essentially precipitate and then analyze via flow cytometry a bead which has pulled one antibody out of a solution of labeled antibodies. And you can see that we can look at anywhere from 0 to 100% labeling of an antibody with either of two colors using this assay. On the right is the experimental result, where in the column labeled induced exchange, we've used temperature and solute conditions to cause the dehybridization of a oligofluor off of an oligo antibody. And as you would expect, you can see this rightward march with time in the labeled beads, and that indicates that, I should mention, by the way, I'm sorry, this is in the presence of a fluorescently labeled antibody with an excess, a fourfold excess of a second oligo-labeled fluorophore. So that second oligo-labeled fluorophore is trying to compete the first fluorophore off of the antibody. And as you can see, when we give it the opportunity with elevated temperature, the assay reports that yes, you're getting fluorophore exchange on that antibody with time. But as the right-hand column illustrates, under useful experimental conditions and under reasonable storage conditions, in this case PDS at 4 degrees Celsius, for up to 17 days, we see no evidence whatsoever of exchange between two fluorophores for that antibody, even with a fourfold excess of the unwanted fluorophore in there. This is also the case in any reasonable set of experimental conditions up to 37 degrees Celsius. We happen to do this at 4 degrees C. The oligos are chosen in sequence and in length to be stable in excess of to be stable as hybrids in excess of 40 degrees Celsius. So you simply don't get exchange is the take-home message here. It is as if these antibodies are covalently labeled with the fluors, although they are not. And I'm waiting for the next slide to come up here. There we go. I briefly just want to touch on the fact that while the HybriLink technology has been developed with the needs of flow cytometrists in mind, I want to very briefly say that we recognize that there are an expanded set of application areas that the HybriLink technology can be expected to address in future. And the company has done some validation studies on some of these applications. It can be used as a substitute for the conventional covalent labeling of beads for bead-based immunoassays. And this just shows in the left panel conventionally labeled beads, and in the right panel HybriLink labeled beads used in an immunoassay situation. It can be used for Western blotting, where again the two panels show a conventional HRP labeled antibody detecting a protein band, and on the right a HybriLink HRP labeled antibody detecting bands on a Western blot. And potentially it can be used in fluorescence microscopy as well. And this shows two examples of labeling intracellular tubulin with a conventional antibody or a HybriLink labeled antibody. So really this is a tremendously flexible technology, and that's one of the most exciting things about it, is what it makes possible for the end user that simply isn't possible today, and that is any antibody in any color for a variety of applications.